Hey, so what I want to do here this morning is do a few examples for you of what I would call solution stoichiometry. So, we learned stoichiometry right after spring break, and then we learned a little bit about gases, and then we applied what we learned about gases to some stoichiometry problems, and we called those gas law stoichiometry. But again, it's just all about finding moles, and in a gas law stoichiometry problem, you have to use Pivnert to find moles. So now we're going to try and do the same thing here. We've been learning a lot about aqueous solutions and how they behave, and now we want to start applying what we know to some stoichiometry problems. That'll allow us to start doing what I call titrations here later in the week. So again, it all boils down to how do we find moles? Because once we've got moles, then as you guys know, stoichiometry is pretty straightforward. So how do we find moles? Well, in an aqueous solution, we tend to know its, I need a color. We tend to know its concentration. Remember, these square brackets mean concentration. And the concentration is given to us in molarity, and molarity contains number of moles of solute, which is what we care about, right? Divided by the volume of the solution. So we're just going to use the molarity equation to help us find moles. And then once we've got moles, then we can do the stoichiometry. Or if we happen to know moles in volume, we can find molarity, as we were doing in our last segment there. So I'm going to give you an example of each type, right? So one where we're trying to find the molarity of a solution. This is kind of what titration's all about. That's coming, like I said, later in the week. And then one where we're trying to use an aqueous solution and its components to figure out, like something about a precipitate that's being formed or something like that, and do some stoichiometry there. And then we'll try and combine it all into, in the gray area between, chemistry and AP chemistry kind of a problem where we're using a lot of this stuff. Okay, so I'll walk you through, and you've got an example of each one once I do that. Okay, so here we go. So for this first problem here, let's just kind of read it here together and make sure we understand what it's asking us to do. So we have a sample of a silver nitrate solution, and we don't know its concentration. But we know it reacts with an excess of sodium chloride to create a certain amount of silver chloride. And then we're asked to figure out the molarity of the silver nitrate solution. So let's just jump back to the other slide here for a second. So we're being asked to find the molarity of the silver nitrate. So in order to find the molarity of the silver nitrate, we need to know the moles of silver nitrate and the volume of that solution. If we know those two things, we will be able to find the molarity. So we need moles of silver nitrate and we need volume of solution. And let's see what we're given already. Looks to me like we're given the volume of that silver nitrate solution already. So really this is asking us to figure out moles of silver nitrate is what it's asking us. And then if we know moles of silver nitrate, again, we can just stick it in this equation over here, right? We know this number here is I lost it already, 325, I think. 325. So we know this number here is 0.325 liters. And so we just need to find moles of AgCl or AgNO3. So moles of AgNO3, and we can stick it right there. Well, how on earth are we going to find moles of AgNO3? Looks to me like we're going to have to do a little bit of stoichiometry because we know something about grams of AgCl, and so we can use that. That was produced in the reaction. We can use that and a little bit of stoich to find moles of AgNO3. So let's write an equation. So the AgNO3, it says, is reacting with sodium chloride to form silver chloride. So this is what I call a partner swap or precipitation reaction. So the silver's going with the chlorine and the sodium's going to go with the nitrate, right? Plus NaNO3. And that looks like it balances all ones. That was really nice. And then what we know is we created 23.9 grams of this guy. And we're trying to find, as we said over here, jump back really quickly, what we need is moles of silver nitrate. So we need this guy. How many moles of that guy? Okay, so that should look like a basic stoichiometry problem to you guys. So we can just do that, just using essentially nothing about solution concentration at this point. This is just stoic. So how many moles of AgNO3 is equal to 23.9 grams of AgCl? And I'm just going to stoich this over. I think there's 143.5 grams of AgCl in 1 mole of AgCl. Just happen to know that off the top of my head. And then looks to me like it's a 1-to-1 ratio. 1 mole of AgCl to every 1 mole of AgNO3. Wow, we're almost done with this thing. So 23.9 divided by 143.5. Wow, and everyone else is a 1. I get about 0.167. And this is moles of AgNO3. And so we're almost done, right? Remember, in order to figure out the molarity, as I was saying up here, what we need to do is take the moles of silver nitrate and divide it by the volume. And that's what we're going to do. So we're going to take the mole, so molarity of the AgNO3 is the moles of AgNO3, 0.167 moles of AgNO3 divided by the volume. And again, the volume has to be in liters. Boom, boom, boom. 0.325. And we got our molarity. So divide this guy by 0.325. So about 0.512 equal. So the concentration of the AgNO3 is I just lost it already, 512. And man, there it is. So, again, I call it solution stoichiometry because we're having to use, get myself another color here, we're having to use molarity and we're having to do some stoich, right? So solution stoichiometry, we're just combining 2 different skills here. Okay, so you'll have a problem or two like that where you're trying to find the molarity and you're going to have to do some stoich in order to figure out moles first. So that's one kind of a problem. Let's look at another kind of a problem, and then we'll look at a pretty big problem where we've got like a lot of things to do. Okay, so the other kind of problem here is we have a solution whose components we know both the molarity and the volume. And we're trying to figure out how many grams of a precipitate that we're going to make. So very similar to the other problem if we were doing it in reverse, right? So before we were trying to figure out the concentration, we knew how many grams of precipitate there were. Now we're trying to figure out how many grams of precipitate are going to form if we know the concentration and the volume. And so let's do that one. And again, it's just essentially the other problem in reverse. I'll show you how. There's several different ways to do it. I'll show you what I think is the easiest way to do it. First thing, man, we better write a equation for our reaction. So HCl is reacting with lead nitrate. So I have HCl, and it's reacting with PbNO3 and it's going to form PbCl2, another partner swap reaction here. This guy's aqueous. This guy's aqueous. This guy's a solid. And our other product's going to be the hydrogen with the nitrate. So HNO3, right? A partner swap. This guy will be aqueous, but it doesn't matter because we're not doing anything about that guy. To balance it, I think I need a 2 here and a 1 here and a 1 here and a 2 here. and I think that guy's balanced. Um, and so what we're trying to figure out is how many grams of this guy there are. And we know two things. First off, we know that the lead nitrate's in excess, which means it's in excess, so it's not the limiting reactant. So we don't care about this guy at all. And then we know how much HCl we have. And this is the point where I told you guys, whenever you know the molarity and the volume of the solution, the easiest way to deal with this is just to multiply those two things together right away. You might remember from our last lesson, the molarity times the volume, as long as the volume's in liters, will equal moles of solute. So to figure out how much HCl we have, we're just going to multiply the molarity, 0.875, times the volume in liters, 1, 2, 3. Got to put a 0 in there. 0.0235. Okay, and it's going to tell us moles of HCl. And man, let's just get rid of the molarity and the volume right away. Let's just get it to moles, and then it's really simple, straightforward stoichiometry, you guys. So 0.875 times 0.0235, I get 0.0206 moles of HCl. Wow. So now we know moles of this guy, and we're just trying to find grams of this guy. We're just going to stoich it over here. Very straightforward, you guys. How many grams of PbCl2 can we make from 0.0206 moles of HCl? Wow, this is going to be so fast. My molar ratio is for every 2 moles of HCl, there's 1 mole of PbCl2 according to my balanced equation, right? There's my 2 and there's my 1. And then I just got to find the molar mass of PbCl2. So for every 1 mole of PbCl2, there's some number of grams of PbCl2. I need my periodic table here because I don't know that off the top of my head. I think the lead's like 208. I'm actually moving across my room here because I was unprepared to have to do this. So I got my textbook out now. Lead is, 207. So 207 molar mass for that guy, 71 molar mass for 2 chlorines. So when I add that up, 207 and 78, I get 71, I get 278. So this is 278, and man, I got this. Okay, moles of this is canceling. And there it is. All I had to do was find moles from my aqueous solution and then do some basic stoich, and that's how simply we can put these two skills together. So let's find our answer here. This guy here times 278, and I'm going to divide that by 2, it looks like. So I get approximately 2.86. So I get approximately 2.86 grams of PbCl2. Bam. So there it is. So we've now done one problem where we were doing some stoich to find moles and then using that to find a concentration. So we combine the two skills that way. And then here's an example of how to combine them essentially the other way, which is if I know an aqueous solution that's involved in a reaction and I know its molarity and I know its volume, I can just multiply the two of those together and that'll give me moles of that guy, and then I can use that to do some basic stoich. So very straightforward combination of those. For this last problem, it's kind of a little bit more of a challenging problem here, but hopefully you'll be able to follow this. So what I'm going to do is combine a whole bunch of skills here. So we have an aqueous solution, right? We have a solid, and we have a gas. Whoa, look at that. So we have all three. And when we have that kind of a problem, we're going to have to utilize a lot of skills, right? We're going to have to use molarity and our understanding of molarity to deal with the aqueous solution. And we're going to have to do some stoich, it looks like, and we got a gas, so we're going to have to use pivnert. And so remember, those are the key skills. When you got a gas, bing, I got to use pivnert. When I got an aqueous solution, bing, I got to use molarity. When I've got a solid, I got to use molar mass, right? How do I convert all these things to moles? So let's write out the equation and see if we can figure out how to do this. So I've got HCl, and that solution is aqueous. Remember I told you these little subscripts here are going to become important as we move along because we need to know how to treat it. We treat a gas different than we treat an aqueous solution, and we treat that differently than we treat a solid. So we have to know what it is we're talking about. We're mixing it with an excess of solid sodium carbonate, so we have Na2CO3, and it's a solid. And what we're doing is we're creating CO2 gas. And I told you guys that one of the things I ruled out as a function of the remote learning piece that we're doing here is having you guys learn and predict what products are going to be from the different reaction types. So I'm just going to tell you what the other products are here. So I'm also going to make water here, which is a liquid. And I'm going to make sodium chloride, which is aqueous. And don't worry about how I got those. Like I said, that's something we would have covered had we been in class together every single day, but we're not. So we're considering that not one of our essential learning. So I'll always give you the products here. All right, so let's see if we can get this thing balanced. I think I'm going to need 2 of those, and I think I'm going to need 2 of those. 2 chlorines, 2 chlorines, 2 hydrogens, 2 hydrogens, 2 sodiums. 2 sodiums, 1 carbon, 3 oxygens, 1, 2, 3. There it is. All right, so we got this guy balanced. Now, let's see if we can figure out what we got to do here. So we know molarity and volume of our HCl again. Wow, let's just multiply those two things together and get moles of HCl. So I'm going to take my molarity, 0.857, and I'm going to multiply that by the volume. Remember, the volume has to be in liters. 1, 2, 3, boom, times 0.0365. And that gives me 0.0313, 0.0313 moles of HCl. Right away I did that, right? So that I'm not messing with this stuff in my stoichiometry somewhere. I just turned it into moles. And that makes my stoichiometry really simple. Okay, what else do I know here? It's mixed with an excess of sodium carbonate. Nice. So I don't have to figure out a limiting reactant. Nice. If it wasn't an excess, then I'd have to figure out who the limiting reactant is. That'd be a really complicated problem. Okay, now I'm being asked to figure out how many liters of CO2, so I'm trying to find volume of this guy. I know its pressure. I'm going to have to pivnert. So its pressure is 0.756 atms. Volume is what I'm trying to find. N, I don't know N. R, I know, 0.0821. Temperature, I know, I just got to get it to Kelvin. So I'm going to add 273, which gets me to 304. And now what I need to do has become really obvious, right? If I'm trying to find volume, I got to know moles here. How am I going to find moles? Well, I'm going to stoich this over here and turn that into moles. Stick the moles right there, and then I'm going to pivnert it. And I got my volume, and wow, I've used all the pieces I've been learning over these last couple weeks in order to solve that. So let me give myself a little bit more room here if I can. Get rid of U and make U a little bigger. And so let's see if we can find moles of CO2. So how many moles of CO2 is equal to 0.0313 moles of HCl? Bam, look at this. 2 moles of HCl to every 1 mole of CO2. And I am almost done. I know you guys can see it now. this guy here divided by 2. So I get 0.0156 approximately, 0.0156 moles of CO2. I'm going to stick that right there. And so PV equals nRT. I'm trying to find the volume, so I'm going to divide by pressure. Divide by pressure. So volume is number of moles, which I just found, 0.0156 times R, 0.0821 times T, 304 Kelvin, divided by the pressure, 0.756. Man, look at us go. We are solving something close to an AP level problem here, you guys. Times 0.0821 times 304 divided by 0.756. I get 0.516. 0.516. It's a volume, so it's going to be in liters of CO2, which is exactly what I was being asked to find. How many liters of CO2 gas? So wow, there it is. So you can see what happens in chemistry, you guys, is we learn a skill, we add it on to what we already know, and we start stacking these problems up. And this is a huge problem here. If you think about it, all the stuff you had to do, you could almost make a final exam out of this problem, because you essentially had to do everything we've done for the last 2.5 months, right? You had to write and balance an equation. You had to do some basic stoich. You had to deal with a gas using Pivner. You had to deal with an aqueous solution using molarity, and combine all those skills. And that's really what chemistry becomes at this point, right? You learn all these little skills. You develop a nice little chemistry tool belt, and you just decide which tools do I need to pull out in order to solve this problem. So there we go. I'm going to go ahead and stop the video there, I think, and let you guys get going on this problem set that I put together for you guys. Where'd you go? There you are. All right, stopping there.